Okay, last little bit, guys, and then we're done. So here, again, we just point out some of the obvious. Domain is the first part here. The codomain, again, doesn't appear to have any restrictions. So we're kind of allowed all numbers in both directions, all x's, all y's. Now, here we have a cubic. So with this cubic, we're going to, again, maybe just try out some values, -2, 0, and 2. So if I fill this in, -2 cubed plus 1, 0 cubed plus 1, and 2 cubed plus 1. So we end up with -8 plus 1, which is -7. With this one, we end up with 1, and here we end up with 9. So we end up with -2, -7, 0, 1, and 2, 9. So if we did a quick sketch of this, -2, -7, this is somewhere down there, 0, 1 will be about there, and 2, 9. So we're just a very rough sketch, but it would kind of look like that. So it is a cubic. It just doesn't have the defined curves that we're kind of normally used to seeing. But if I do a horizontal line test, I can see that it touches exactly once. Now, if it's exactly once, we can say therefore it is bijective. And if it is bijective, then it does have an inverse. Okay, so remember the key thing here is for it to have an inverse, it has to be bijective, and it only has one inverse. Okay, there are two things, two comments we made at the beginning. Now, the very last thing is how do we graph them? Well, this actually couldn't be easier, so this will be very, very quick. It says if PQ is a point on the graph of some function f, then QP, so in other words, the other way around, is a point on its inverse. The graph of f and the inverse of f are reflections of each other in the line y equals to x. Always use the same scale on both axes when finding the inverse of a function by graphing. Now that is very important. It has to be the same scale. So you can't, you know, the way normally it doesn't really matter if all your x's are equal distant apart and the y's are equal distant apart, that's usually fine. But in this case, your x-axis and your y-axis have to have the same scale. You can't just go up in 3s or up in 2s, or, you know, if the x's are going up in 1s, the y's go up in 1s. Right, so sketch the inverse. So how would I sketch the inverse? Well, what I would do is I'd come along and I'd find any point on the graph of points, maybe three or four of them. So let's start with, say, this one here. So very clearly, I know that is the point 0, -1. Up here, for example, that's the point 1, 2. I could pick others, but because it's a straight line, 2 is enough. So the inverse would be the other way around. And that's all, literally the other way around. So let's plot the new points, -1, 0, and 2, 1. Now, if I join those up, so if I join these together, sorry, I'm just trying to get my ruler here so it's a bit neater. There we go. So if I join these together, that should be my inverse graph. Now, the only way to fully kind of tell whether it's the inverse graph is if we look at the line x equals to y. Now, remember that line y equals to x or x equals to y is that one. So remember, it's supposed to be a reflection. So what we're really saying is that true? If the black was wet paint, does it print onto the orange when folded along the green line? It does. So that's how I know that I'm definitely correct. So this is the inverse function here. That was the original. This is the inverse. And this is the line of reflection. So let's do that again. So pick any points that you can see on the graph. So for example, 1, 2. And for example, it's a little bit harder with this one, I guess, but let's see, we could pick, I mean, even something like 1.5, 4.5. No, that's okay as well. So 4.5, something like that. Now, remember, we have to just switch them. That's all we have to do to get the inverse. Just literally switch them around. So let's graph the new one, 2, 1, and 4.5, 1.5. Okay. So, and it's going to start in the same spot. So it's kind of going to look like that. Okay. Now, again, if we put in our y equals to x line, would this make sense? Would this look, I'll just do it as best I can. Okay, that's probably as good as I'm going to get it. So if this, again, okay, that's not great, is it? No, it's not great. Okay, and maybe I'll just freehand draw this one. Sorry, sometimes it's hard to get the ruler to line up. But you get, I hopefully you get the idea. Oh, that was actually very good. Okay, so basically, if this was wet paint, would it print on the way I've said? Yes, it's not perfect, but you get the idea. The black would print onto the orange. Okay, we'll try 2 more and then we are done. So this is the point 1, 3. This is the point 2, 4. Some of them are easier because, they pass through so much nicer. 3, 7. We just switch them. 3, 1, 4, 2, 7, 3. So I'm going to do that in orange. 3, 1, 4, 2, 7, 3. Okay. So there we go. And again, if I put in my y equals to x line, would the black print onto the orange if I folded it across where the green is? Absolutely. So we know that it is an inverse. And very last one, we have -2, -1, -2. Might pick this one here as well. 0, -1, 1, 0. Okay, and then we just switch them. -2, -1, -1, 0, and 0, 1. And I'm going to do this in orange. -2, -1, -1, 0, and 0, 1. Okay. Also our green line, so we might just pop that in as well as we're at it. Okay. So we want to make sure that when we, have I done that right? Sorry, I'll just double check that one. -1, -2. Yeah, that should be okay. Actually, it might be no harm now that I think about it. Maybe we could do one in here, it's not going to be perfect, but it'll get us kind of the path or the idea, or maybe even that one. So like, let's say we did that one, that would be kind of minus maybe 0.8, -1, say 0.3. So if I switch that, it's -1.3 minus 0.8. So if I did -1.3 minus 0.8, it would be kind of like there. So I was just explaining, I suppose, that might help with the paths, so to speak. But anyway, you hopefully get the idea at this stage that, again, if we were to fold it along the green line and the black was wet paint, would it print onto the orange? Yes, it would. And that's our inverse functions and our graphs of inverse functions.